Good afternoon. This is Bill Alderson. Thank you for joining us. I'm going to do a presentation on network management in the theater of war. This is a presentation that I did at the MILSYS conference last year in Australia. So a lot of fun going down under and talking to some of our military counterparts down there about network management. Had a good time, and anyway, appreciate you joining us today. A little about me. I consider myself an application and network performance analysis advocate. I know that end users are the most important folks in my career. I focus on working toward their benefit in everything that I do. I started out at Lockheed in Sunnyvale, California, the heart of the Silicon Valley, and I was there from 1978 to 1984, and I was a communications analyst. I was the young guy that loved communications and, was with every kind of computer that was coming out at the time, IBM, Apple, others, and so I was right in the middle of it. It was a lot of fun. A little later on, got working with Network General and the Network General sniffer at the startup, and then I took my experience with the sniffer and I founded Pine Mountain Group, created Network General sniffer training, which Network General licensed from me for a number, in perpetuity. So all those folks who went through sniffer training have been affected by me in some way. And then Pine Mountain Group, we trained about 50,000 people in 22 countries and certified over 3,000 network forensic professionals. A lot of work. 75 of the Fortune 100 federal and state government agencies. I did a big event for Networld Interop called Network Forensics Day. Sold Pine Mountain Group to NetQOS in 2005, and I was the technology consulting officer there. CA then acquired NetQOS and hung around as principal services architect. Then just this last year, I founded Appalytics Corporation. So I've got customers at Appalytics. We did a subcontract to U.S. CENTCOM, where we went and did analysis of pretty much the entire war area. And so that's kind of what I'm talking about and some of the things that I learned through that experience of looking at every network control center throughout CENTCOM's AOR in all those various countries, and then working with those systems to upgrade and architect, document their systems so that we could perform network management, etc. I'm also a consultant to the OSD-CIO at the Pentagon and Area Communications, and I also provide services to the Department of Justice. So I've got a pretty wide variety of experience. The talk today is about network management, but in order to understand network management, one must understand everything from end to end, from the client, where you got the user, the business transactions, the security access, the application interface, the operating system, the computing platform, the OSI model, the 7-layer model that brings it down to where you can take all of your data across disparate networks and systems and then arrive at the server and get error checked and that sort of thing. So we're basically looking at the full spectrum of everything end to end from client to server. Well, one of the things in the war area is that there's a lot of different people and a lot of different organizations that are in charge of the packets from where the warfighter puts a packet on the wire and until it gets to the server. And so consequently, in that traversing all of these different network management zones and different countries, continents, going up to space and back, these packets are really mistreated But everyone along the path has their own SLAs, their own network management systems, and they're all different. And by golly, if you go through and you talk to anybody, all the contractors and everybody involved, everybody did a wonderful job, all met their SLAs, everybody inside those silos is very happy, with one exception: the user. The end user is going across all these dissimilar systems, and when he's got a problem, where do you go to capture the packet if it doesn't get there? Who do you blame? Who do you call up? Who do you talk to? So the end-to-end analysis that I've done from all those areas back to CONUS for different applications and that sort of thing basically said, hey man, if you're an end user, you have no advocate. You have a centralized advocate. It's very, very difficult. You can call your local guy, and he'll do local things, but he always comes back and says, must be somewhere else. So now your end user is in trouble. So those end users are the ones that usually contact me. Powerful, high visibility, high stakes end users usually call me up and say, hey, and that's exactly what the military did. They called me up to have me help with the application, and we went out and looked at all their network management and said, well, you don't know where any of your packets are going. You need some net flow information. So we implemented net flow across the entire AOR so that you could see what applications were running where. And in particular, one biometric application. It was very interesting. It was awesome to analyze this application. I helped the programmers actually recode several parts of their application to improve performance and that sort of thing. So it was a really good thing. So, you know, network management does not just involve the purchase of some network management tool and then turning it on and installing it. It involves understanding the clients that are accessing the applications that are going through it so that you can fine-tune it, nurture it, so that you can find the signatures of the vital signs of those applications. When somebody tells me, you know, about network management and, oh, yeah, I'm a network management guy, well, do you know applications? Do you know the issues on the client? Do you know the issues on the server? Do you see the virtualization issues? Do you see all the man in the middle, all the firewalls, all the WAN optimizers? Do you see all the load balancers and that sort of thing? Do you understand how those things come into practice? Do you understand the quality of service across that end-to-end network? Well, I know everything there is to know about this network management package and install it, and I've installed it. Yeah, but in order to install and use these systems, you must intrinsically understand what it is you're trying to help the clients achieve and how to measure the performance of those systems all along the way. You've got to document your system. So I'm going to talk to you a little bit about, after we get off of this slide, a number of things. I've got a lot of slides to cover today, both there and you know, very quickly and give you a cursory overview. So here's your basic client to server. So a client is separated from the server. We started doing that back in the late 80s. And you took your client and your applications, you run it across various stacks using HTTP or Java. You go across your transport network, you come up the other side, you go into your server, you pop back up your stack and into your respective upper layer system, and then you go into your applications and processes on your server. So you have to draw this out. You have to know where your connection points are. You have to know where you are in the universe. And if you're having a problem somewhere, you need to know exactly how you're going to hook in, where you're going to hook in, what kind of tool you're going to use so that you can deconstruct the problem. Now, people going into the cloud, and that'll be another topic that we talk about, but you know, cloud computing can be problematic because with client and the server, you own all the infrastructure. But when you put that server over in the cloud, you have no access to packets, network management information, statistics, etc., other than what that vendor gives you. it's going to be a cloud, all right. So basically, I'm trying to help you understand that, when you go in to analyze your environment, you need to know from end to end. So here's a client talking to an app server or an HTTP server, and the back end is talking SQL or some other type of middleware or back end process. Well, you have to know where to go to connect your network management systems for packet capture, for metrics, for analysis, and so that you can understand, and if anything goes wrong, we will, at one or another, and you will need to get macro information about the use of the network, the use of the platform, the CPU, etc., of all the different systems. You need to see the entire system from end to end and understand all of the various components so that you can basically design the vital signs for the applications and systems. It's as simple as just being, okay, I'm monitoring layer 3 of the network. You have to be a little bit higher than that. You have to help your customers. So that's my definition of network management. Now, typically at one time or another, whether during implementation or later on, you're going to have a problem, and you're going to be looking for that proverbial needle in a haystack. So here's your needle in a haystack. It's out there. It's somewhere. Let's take a look where it might be. It could be anywhere in Afghanistan, Iraq, or some point between, or over somewhere in the United States, or down at Fort Huachuca. Your packets are traversing all of these various environments. Where is it? What's slowing it down? Who's holding it up? Who's routing it? Who's misrouting it? Who's redirected it? Who changed it in its path because of a WAN optimizer or a load balancer that you're unaware of? Those are your men in the middle, and they're sitting out there impacting your environment. So you need to know your environment. And then every once in a while you got to gather some packet traces, and you gather them from somewhere in between where the user is and their resultant service. So it could be anywhere. So you usually go and gather packet traces. What are packet traces? Based upon macro information that we get from our network management system that kind of tells us and help us triangulate where the problem might be. So that's what we use network management for, and then we'll go out and we will capture some traces and then get down to the bottom line. And let's tell you right here, and you can all argue with me, you can fight with me, if you are a network management person and if you are implementing large-scale systems and you have no ability to capture packets across your path, you are impotent. You can't do it, you never will be able to do it, and I'm telling you that if you don't have, bottom line, cause, deep packet analysis skills and capabilities and the ability to capture those packets, you are impotent and you cannot do your job, because sooner or later you're going to come up against a problem that absolutely requires deep packet capture. So you design your network management systems to help you find the area and then zero in on it. Can you solve many problems with network management systems and capacity? Absolutely. Can you solve every one? No. And not a very pretty picture when you're standing around with several $1 million worth of network management tools giving you charts and graphs and all sorts of wonderful views of stuff, and you can't solve the problem. It's because you don't have deep packet capture capability. You don't have the root cause analysis capability. So that's what I focused my whole career on, trained 50,000 people, and executed for 75 of the Fortune 100. To help them solve these type of problems. So then some people say, well, I like packets so much, I'm going to capture every single one and I'm going to store them forever. And I ask, okay, you're going to store every packet everywhere. You've got, unlimited amounts of money and resources and storage. Who's going to analyze those packets? Who's qualified within your organization? How are you going to filter in and have the offending problems bubble up? What's your strategy for using these systems? A lot of folks have a lot of this sort of stuff up in their environment, and they have all these tools and capabilities, but nobody ever goes and looks at them. Oh, but they're there in case we need to do retrospective. Well, that's good, and I'm not saying you shouldn't have any of it, but I'm saying that you better make certain that if you're going to buy this stuff, turn it on and start caching packets all over the world. You at least ought to have somebody who's around who can help you take a look at them and know when and why. So we finally get down to the stack with the problem. Now to work in deep packet analysis to deconstruct in order to ultimately, boom, the needle in the haystack. So that's what it's all about, is getting to the bottom line. Definitive results, performance orientation, get the job done. No ifs, and wells, or buts about the situation. So, in order to get all that done, we use ITIL, we use people, processes, paradigms, tools, systems, platforms. We use all of these various systems. It's not just network management. It's not just deep packet analysis. It's not just application optimization. We have a whole portfolio of capabilities. But as I'll talk about in some future, I have a list of these things that I believe are the most important, and we'll talk about those at some point. Actually, on the 30th of the month, we're going to talk about that. It requires a seamless integration of people, process, knowledge, and technology. So it's a well-rounded organization. So I'm going to talk to you a little bit about what I call my network management servo loop. Over on the left, you've got a website, let's say. You've got an application, and you want it to perform. And let's just say that you want it to perform, and you want that web page to come up within 15 seconds. So what you do is over on the left-hand side, you say, I want the maximum possible performance to accomplish this business objective, and I'm going to set my command, my desired response time to be at 15 seconds. So that goes into the network management servo loop. This is a feedback servo loop mechanism. If you haven't seen this before, it's a very, you can look it up on the internet and see some other, but I have taken and adapted this because it's a feedback loop and it's a servo loop. It's a closed loop system where you say, this is what I want and expect from the system, and then you have a resulting actual user experience that you compare to what it is that your objective is, and you come up with a signal deviation. So at the top left there, you have what your desire is, 15 seconds. You have your feedback signal, which is, let's say it takes 25 seconds. So you have a signal deviation of 10 seconds. You are not meeting your SLA or your desired performance by 10 seconds. So what do? Well, in most environments, executive management thinks all the technologists have it all figured out, and the technologists think that the executive management have it all figured out. I have news for you. I've been working in this industry for 20-some-odd years. Neither one of them really know and have a systematic approach and to get them into the servo loop. Let the executives in there. Let's show them some metrics. Show them some business metrics. When you talk to an executive about their business metrics and how it coincides with the network and the application metrics, they start listening. You don't lose them in presentations. You have their full undivided attention because you're talking about deliverables for the business. So I always like to get metrics, feedback sensors. Part of those are a metric that are part of the business. Performance indicators and user reports, right? So you get your executives involved because why? Because executives control the policy, procedures, the resources, and the entire organization. They need to be involved in this, okay? You take a guy like Steve Jobs, okay? And he was involved in the process. He understood his company's technology. And then you take another guy like John Scully, and you put him in there who's selling, sugar water for years, okay? He's bottom line dollars guy. How much can we make? But in technology, you have to have someone involved in the technology. If your executives are not involved in the technology, it's your job as the CIO or the executive technologist to get them involved in a meaningful way. And the way that you do that is you pop in some business metrics and you compare them to some of your technical metrics, and you'll bring them right in. They'll get involved and help you solve the problems that you have by allocating resources, priorities, focus, policy, and budget. Then you got the actions. The actions are carried out by the technologists and the technology folks, okay? They go out and they apply. They're the tinkerers. They're the guy behind the curtain, changing this knob, changing that knob, optimizing and installing and improving the environment and the systems. So, after executive management, puts the controls on there, the technologists apply those priorities, and then we should then measure again the actual user experience. We measure the actual user experience. It comes back, okay, and little by little, between the executive function and the technology functions, we start to move the servo loop toward the maximum possible performance. We keep tweaking it, but it does involve executive management and it does involve the technologist. If the executives are not involved, you have the type of priority and prioritization and resources necessary. Okay, so now let's talk performance indicators. Well, these are the three main performance indicators they advocate for. You've got network flows. Network flows are from the left, you've got clients, and you've got an IP address, and you've got a socket. And those are the application sockets. So if you know every packet that goes across your network, because every router in the network is reporting on these network flows, you don't need another gizmo to pop in there. Those routers perform the actual task of looking at all those TCP connections from IP address on the left at the client and IP address on the right at the server and the application ports that they're using between those two, and they tell you, they record the rate and flow volume information, so I can tell you if an application is or isn't working well, and how many people are using it. Why? Because I have rate and flow information, and it's coming from my routers, and it's just going to a database, getting a database, and I can go back and tell you what applications are on your network. And that was very interesting in the war environment, because there were certain applications that were consuming large amounts of bandwidth and others that were consuming hardly any bandwidth, and some of them were being accused of consuming bandwidth that they weren't, and some of them. So when you really go out and get the facts of who's talking to who through whom, right? The bottom line, that's what NetFlow does. Who's talking to who through whom. And you've got rate and volume information, you've got capacity planning, you've got all of those sort of things available at your fingertips. So NetFlow and network flows is a very important thing, because it tells you where those applications are running around the world and who is running those applications by location. And the volume and the rate can be compared and tell you what type of performance they're getting. So if you understand the theory, you understand the network management. So again, this is not about turning up a product. This is not about clicking and installing a product. This is about buying it, installing it, and having it there. It's about interpreting it. It's about looking at it. It's about architecting it. It's understanding the applications. It's understanding the vital signs. It's about trying to figure out what's going wrong and where, and being able to triangulate that and being able to solve those difficult problems. Okay, so they've got standard SNMP. That's device status. SNMP just tells you a router's overloaded with CPU, or a circuit is overloaded, or an interface is overloaded. It's very good information. But what if you don't even know the path that your packets are taking? So you got to know the path that your packets are taking. If you know your path, then you can exploit device status to find out what devices on your particular path are impacted by memory, by CPU, by other types of capacity limiting characteristics. So the first thing is you got to know your path. Well, I have very many tools out there and capabilities, at layer 2A and 3. You can get a layer 3 path, but it's hard to get a layer 2 path as well. Okay, so you've basically got the flows, you've got device status, and then third, response time. Response time monitors, there's several different flavors. OpNet has some really nice stuff. NetQoS, which is acquired by CA, has some nice stuff. And there's a couple of other players in the field that don't have a lot of confidence in quite yet, but it's growing because this performance marketplace is, it's no longer about red, green, up, down. It's about, something's wrong. We know where. It's working, but very well, and it's impacting our end users. So we put these response time monitors, which basically capture the packets or listen to the packets as they go into the server. They timestamp it at the server, and they say this packet response time took, 100 milliseconds. And you can put timers on these things and thresholds. So if your response time is slow, you automatically trigger a trace file. So you don't have to wait until 2 in the morning. You can actually have your response time monitor over monitoring a bank of servers, and when the response time gets slow, it automatically triggers a capture so that your technologist can go back in the next day and do retrospective analysis on the packets that were slow. So do we care if everything is fast? Do we want to capture all those packets? No. What do we want? We want to trigger on the events that are poor, and that's what these systems do. They record the response time. It's an awesome system. And it also gives you the network round trip because the ACKs come back and it records that so you can see. And one of the problems that we had was satellite delay and multiple route hops adding satellite delay. It's about 700 milliseconds round trip across a satellite. We want to see a response time that says it's 2.1 seconds. I know that 2.1 seconds is because they've gone across 3 satellite hops, because 3 times 700. So you can figure out and start to surmise what's going on, and then you can look at optimizing your routing. Okay, so these are your tools and your key issues. So you've got your performance management system, you're getting your performance metrics, the feedback, your business metrics, you're getting your trouble tickets, you're getting your information back. So some of the things that you need to look at is route analytics to identify instability in routes, server response time, net flow-based rate and volume information, gives you hints on conditions, limiting user stuff. SNMP device status, well, you got to know the path in order to know what devices are in that path, and because you may have hundreds or thousands of different devices. So knowing what your particular path is and exploiting that path to see if anything in that path is failing, that is value added. And then, of course, packet capture at key locations so that you can get down to root cause analysis. Okay, here's a network management architecture diagram. There's a portfolio of tools. You've got remedy trouble tickets. You've got OpsWare, ArcSight. You've got a large number of different systems, packet designs, route analytics, NetQoS's response time monitoring, and NetFlow tools, OpNet's network diagramming capability. There's a portfolio. It's a Swiss Army knife all working together. You can't use just one company, one suite of products. You can reduce that set as much as you possibly can, but you always want to make certain that you've got every best of breed in every aspect of the system. Okay, so this is where we went out and installed systems at 15 different sites across Afghanistan, Iraq, and areas in the United States so that we could have NetFlow and response time monitoring. And this is how long it took us. It took us 1 year to install. This was pretty much unheard of. It was the ability to get this system up and running and actually do analysis on major applications in under 12 months inside a war environment was unheard of. We had an incredible team down at CENTCOM and out there, war fighters, man, they were working their buns off to try and help us get all this stuff so that we could figure out what was wrong with this biometric application. This biometric application, by the way, took fingerprints and iris scans of the bad guys, and it looked at latent prints of the guys who were building bombs and that sort of thing, those IEDs, and that application was helping them put those bad guys on an alert list. And so a warfighter would have a bad guy walk through, or people would be walking through their security station going into Fallujah or into Baghdad or whatever, and they would immediately pick up on the fact that thousands of people were coming through, and we just found a guy that had a latent print on an IED, and this guy is now caught. And that's how the surge actually worked, in my opinion, was because we had electronic means to zero in on who's a bad guy and who's in proximity and who's not. So this application and the analysis of and the fixing of this application really helped the effort over there. So we found route changes due to packet loss, slow server response time. We found problems with TCP offload engine. TCP offload engine is where the TCP stack is moved from the server, inside the server using the server's CPU and memory, onto the network interface card, and there were some problems, and I'll show you a couple of slides here on some of the examples of this sort of stuff. Of course, this took many weeks and months of analysis after we had all this stuff put together, but we found all these problems and started mitigating them, and things improved, and that application I was telling you about was even more effective in performance things. So across the network, quality of service incongruities, network and application issues requiring packet level capture. We analyzed a lot of stuff. So here's a few screenshots of some of the stuff. Here's some route change analytics going on. Here's satellite retransmission. It took 3.5 seconds to retransmit across many of those satellite circuits, and this is a detailed analysis of that sort of stuff. Here's TCP offload engine recovery issue. These are all commercial off-the-shelf stuff, right? And in the U.S. or other parts of the world, these particular systems are not always found to be wanting in a low latency environment. But you put them in a satellite environment with high latency, and manifestations of severe problems start to show up that wouldn't show up otherwise. So we found TCP offload engine problems. We also found WAN optimizers and load balancers and other things doing weird and funny things. I called them our own man in the middle, and I developed a method by which we could identify those man in the middle, and that's one of these, this is some of the analysis associated with that. And then processing analysis, how long it takes. So over on the left, you see processing. That was before we optimized the application. Over on the right, the same transaction only took under 2 seconds instead of 18 seconds. And you add those type of optimizations up, and you've got a lot of optimization. Then data duplication. What does data duplication mean? Data duplication is when you have a problem with that TCP offload engine where you're sending the same data multiple times. And this is an example of where the data is being sent across the network. So not only did you have clogged pipes, not only did you have networks that were saturated, but now you're sending multiple copies of the same data. Here is an example of that packet loss-induced TCP offload problem and the wasted bandwidth associated. So you'll see a red line and a green line. The red line was the wasted bandwidth. The green line is what was normally required. But in this particular environment, because of that TCP offload engine we had and the packet loss that was associated with it that triggered it or was the catalyst. See, if you have no packet loss problems don't manifest. But when you do have packet loss, you end up with 3.5 second response times. You end up with data duplication, And so a lot of things that are exacerbated because in a war environment, you are not dealing with perfect commercial communication systems. So, bind. Multi-tier identification of your environment. You have to know and document your network, and then you set your test points up. Your front-end tier, your middleware tier, your SQL tier. You have to know how to find and design your network management and your response time monitoring and NetFlow systems. So in order to do that, you have to document very well, effectively. Then you can instrument. You can instrument your front end, your middleware tier, your back end tier, your mainframe tiers, and you can then take and instrument your systems. This is basically showing test point 2, where we pulled over to a super agent to do response time monitoring with the ability to capture those packets like I talked to you. When the response times get slow, it would automatically capture packets at that location. So, together, what do you have? A user clicks on their screen on the top left. You see where it says user click? Then it comes down, and over on the right, the different colors, red, green, blue, those represent processing time, network serialization, transport, and switching queue times, and then, of course, security authentication. How long does it take to authenticate the user to be able to access that data? So take a gander. Up at the top left, he clicked, and on the bottom right, the user finally gets the information. Now, did that take 15 seconds or 25 seconds or 61 seconds, what have you? And then basically take it with the next step, and you bring it down to the various tiers. And the process, where is it? So we fixed the process problem in the application, reducing the response time, and this is an example of what some of those response time monitors look like over there. So you've got your web tier monitored at the same time as your app tier, your SQL tier, your mainframe tier, and we found the process at the app tier that was causing a lot of issues, and we helped resolve those. So I'm going just a couple of minutes over today, but I just wanted to finish this out. You know, that the bottom line is, in order to find that needle in the haystack, in order to make certain that your users are productive, you have to design your systems not to find problems necessarily, but to nurture and build a system whereby you are obviating the problem. In other words, you are fixing the problem because you have such good intelligence on the information. In The Art of War, the first thing that's said is know yourself. Know yourself. Document yourself. Monitor yourself. Know where you are so that when you do have a problem, you go over and you can find that needle in a haystack using scientific automated capabilities. The future of network-centric warfare is dependent upon having these type of capabilities. Just buying a bunch of stuff and installing it is not what is needed. You have to have architects who are looking at this, who understand the big picture, and who can solve problems in all manner from client to server and all points between. So if there's anything that we can do to help you, we know how to do it, we've demonstrated it, and we're at your service. So it was good being with you today. This is Bill Alderson, signing off.